Hi, welcome to Physical Science 0.2 on pH. pH is the study of a substance's acidity. You've been given a handout that looks like this. That's the front and that's the back. And that's what you're going to take notes on today. So let's get started actually on the back. On the back, some information about the pH scale itself. The pH scale measures how acidic or basic a substance is. It ranges from 0 to 14, but we will only study 1 through 13. A pH of 7 is considered neutral, pH less than 7 is acidic, and a pH greater than 7 is basic. Now turn the paper over to the front. On the front of this worksheet, you have a little section for examples on the far right side. We're going to fill those in, and some of them have more than one example, so be sure that you fit everything in that same box. So let's start at the top with a pH of 13. You have bleach, lye, and drain cleaner. That is all going on a pH of 13. A pH of 12 is soapy water. Now, this is like heavy-duty soapy water that you would like blow bubbles with, soapy water, okay? A pH of 11 is ammonia. pH of 10 is milk of magnesia, bar soap, and hand soap. A pH of 9 is baking soda. A pH of 8 is salt water or seawater, and eggs. A pH of 7 is blood, distilled water or pure water. A pH of 6 is milk, shampoo, and urine. A pH of 5 is coffee, beer, and bananas. A pH of 4 is tomato juice. A pH of 3 is orange juice, soda, vinegar, and apple. A pH of 2 is lemon juice and vomit. And a pH of 1 is gastric acid, HCl, which you'll learn about later, and battery acid. That should completely fill in the example section of the front of this notes page. So again, still on the front, the rest of the pH scale is talking about the concentration of H positive ions in the solution. So you have, across the top, you have a type, the OH negative, POH, H positive, and then the pH, and then examples. Now the pH is filled in for you, and the examples you just filled in. But now we're going to fill in the rest of that chart. So you have a pH that goes from 13 to 1, and you already filled the examples in. So we're going to start with the type, okay, and we're going to start at the top. So pH of 13, 12, and 11. Grab that little handy dandy pointer of mine. 13, 12, and 11. These three right here have a strong base, or are a strong base. And you can just write SB if you want to, or strong base. A pH of 10, 9, and 8 have a weak base. A pH of 7 is neutral. The pH, the type of solution for 6, 5, and 4 is a weak acid. And 3, 2, and 1 are a strong acid. Okay, so they're in little groups of 3 except for 7. Okay, now you're going to jump over to the H positive column. In the H positive column, this is the concentration, and we're going to talk about that in a minute, the concentration of H positive in the solution. So a pH of 13 has an H positive of 10 to the negative 13. A pH of 9 has an H positive of 10 to the negative 9. A pH of 5 has an H positive of 10 to the negative 5. And you can see that the H positive exponent matches the pH. It's just negative. So you should be able to fill in the rest of the H positive column. Okay, now we're going to pOH. The pOH, since the scale actually goes from 0 to 14, the pH and the pOH add to be 14. So the pOH of a pH of 13 is 1. The pOH of a pH of 10 is 4. The pOH of a pH of 9 is 5. The pOH of a pH of 7 is 7. 6 is 8. 5 is 9, and so forth. Again, you should be able to fill in the rest of that chart from 1 to 13. Then we have the concentration of OH negative. The concentration of OH negative matches the pOH just like the concentration of H positive matched the pH. So an OH negative of a pH of 13 is 10 to the negative 1. See how they match? Negative 1 and 1, negative 13 and 13. The OH negative concentration is negative 5, 10 to the negative 5 for a pOH of 5. 10 to the negative 9 for a pOH of 9. And again, you should be able to fill in the rest of that chart. So now go back to the back and we're going to talk about the concentrations. Concentration, if it has more H positive, it's more acid. The higher the concentration of OH negative makes it more basic. And concentration works like this. If you had a concentration of 10 to the negative 4, that means that for every 10,000 ions, 10,000 ions in the solution itself, only one of them is an H positive. And it's because 10 to the negative 4, and this is the part you should definitely write down at the bottom, 10 to the negative 4 is 0.0001, which is 1 over 10,000, which is a weak acid. That means that you have one H positive for every 10,000 ions in the solution. Now, last thing on the back, you have several characteristics of bases. Characteristics of bases, they again go from 8 to 14. We only study up to 13, but they go to 8 to 14. They will taste bitter. Now, please, when we do the lab, don't taste anything unless I tell you to. Okay, they'll taste bitter. They'll feel slippery. If you feel them between your fingers, it'll feel slippery or slick. They have a higher concentration of OH negative ions, and they pass the litmus test by turning blue. So if you dip red litmus in, it'll turn blue-purple color. If you dip blue litmus in, it'll stay blue. Finally, you have the characteristics of acids. They have a pH of 0 to 6. They will taste sour. Now, I don't know if you know this, but you actually only have 4 taste buds in your mouth: sour, sweet, salty, and bitter. And so when you taste something, some people love Sour Patch Kids, and that is because their taste buds like that. They have more sour taste buds than they do anything else. People who don't like sour candy have probably more bitter or sweet taste buds than they do sour. Okay, characteristics of acids, they have a higher concentration of H positive ions. They're used in pickling, right? You ever had a pickle? We used an acid to make that pickle. And then they have a red litmus test. So the red litmus will stay red and blue litmus will turn red or pink. You're going to be doing an assignment on pH today, just using your notes. You also have a virtual lab before we do the physical lab next class. Thanks for watching.